Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Today, we're taking a break from the summer of Cscape to bring you what I think is a really interesting topic. Here it is. Inxpect Radar and the Horner OCS. The Inxpect radar system was something I first discovered about a year ago when I was attending a technology fair put on by our distributor PowerMation in Alexandria, Minnesota. And I thought it was really interesting and I wanted to bring it to our channel at some point, and we're going to do that today. And to help me bring you this technology, I'm bringing in a colleague of mine from PowerMation who's one of the experts at their company on this particular product line. All right, let's take a look at how we're breaking down today's topic, and then we'll bring him in. All right, we're going to start out by bringing in my colleague from PowerMation, and with him, we're going to review the following. We're going to answer the question, what is the Inxpect radar system? What are some of its advantages, its features, its application? We're going to review the Inxpect system components, and then we're going to talk about integrating the Inxpect with Horner OCS through a block diagram and some programming examples. All right, here we go. Okay, so without further ado, let me bring in my colleague from PowerMation, Adam Bone. How are we doing today, Adam?
I'm good, Chuck. How are you doing?
I'm doing fantastic. So I really appreciate you joining me today. This is a technology that I just told the audience that I was really kind of excited by about a year ago when I first saw it at one of the PowerMation Tech Fair. So thanks for joining me today and helping kind of show our customers around with the technology.
Absolutely. It's definitely something I'm excited about. It was a great project to work on over the past couple of weeks and something I'm excited to share with everyone.
Awesome. Sounds good. Okay, so before we dive into that, why don't you give us a little bit of background, introduce yourself, give us a little of your background.
Absolutely. My background is in industrial engineering. I went to Iowa State University, started out mechanical, graduated industrial. I also did the sales engineering minor there, which was how I found out about industrial sales, industrial automation, and technical sales. Found out about PowerMation through the Iowa State Career Fair. Was excited to join the company because it was a chance to work in a customer-facing role, but really get to embrace the technical side of things. Everyone at PowerMation has done a great job of being an example of how you can be a technical resource for your customers, as well as a good person that they can reach out to with anything that they need.
That's definitely my experience with PowerMation, no question about that. So you're pretty new at PowerMation. How long have you been there?
Yeah, I've been here for about 12 months now, 12, 13 months. Started out last year as soon as I graduated Iowa State. I've been doing the Technical Sales Associate program, which is a great thing that PowerMation offers. It puts you through rotations in inside sales, solutions group, doing some of the value-added work and some engineering work. Puts you through business development, which is how I get to work with our vendors like this. I get to work with our product experts, Jeff Johnson, who is the Inxpect, our general safety expert here at PowerMation, Andrew Jager, who I know you've had on a couple of times here, works a lot with Horner, and everyone else from robotics to motion. It's a great way to get engrossed in every aspect of PowerMation and really get to learn our internal systems so that we can better serve customers when we go into outside sales, which is kind of where I'm at now.
Yeah, so that's one of the advantages of starting out with a distributor who has a lot of automation products in their basket. You can learn to integrate those. You can learn all about different technologies. Very cool. All right, so without further ado, why don't we go ahead and dive into today's topic?
Absolutely. So today we're going over a demo that we initially added to just the Region 2 Wisconsin office here in Milwaukee, Wisconsin. It was in addition to our fencing safety demo, so it allowed us to expand that demo out from just being our previous safety offerings to also include this enclosure that we're going to show here, the Horner X10 that we used as the HMI, the interface, as well as having our Inxpect radar safety sensors. So one of our newer technologies to PowerMation, but something that's really unique that we get to bring to the marketplace here in the Midwest. Inxpect radar-based safety sensors. It's a system of the sensors, up to 6 sensors per controller, and then your Inxpect controller as well that you configure in their software. And if we go ahead and go on to the next slide, we can see a little bit of the different benefits of these sensors. So these are great advantages over optical-based safety systems. is that they're not affected by light. It's a full radar-based system, which also gives a lot of durability to particulates, to fluids. And so these are great for welding applications when you have a lot of, let's say, robotic welding, you're gonna have a lot of weld splatter.
Sure.
And it would be very difficult for an optical-based system to operate in that area. Some benefits over light curtains is that it's volumetric, so you're able to monitor an entire area, not just a singular plane. And it's great for dirty, dusty environments. And if it really gets bad enough that you're worried about it caking up the front of the sensor, these do read through a variety of plastics or non-metallic enclosures. So you can actually put it in a controller, wash that down, and keep your sensor running right.
Well, that's cool. Now, I know we've got a lot of customers that are in the woodworking industry, the construction industry, building trusses and those sorts of things. And believe me, firsthand, I've seen a lot of sawdust, a lot of debris in those sorts of environments. Cool. All right, so let's talk about some of the applications. So you've already mentioned the fact that, okay, so these are three-dimensional, which means that, with a light sensor, for instance, or an optical-based sensor, usually you're talking about a two-dimensional plane, right? Whereas these are more three-dimensional, which is obviously a big advantage. The first application that I was reading about, on the Inxpect documentation was smart collision avoidance. So what's that all about?
Absolutely. For mobile applications, whether this is putting one on a crane or a hoist, or if you're putting it on an AGV that's going to be operating around in a facility, it's great to be able to see not just the field in front of you, but also up. If you are going through an area and there's an obstacle that would impact your device, but it's not in the direct plane that the device is sensing in, like a laser area scanner, it can be incredibly difficult to detect that with other technologies, whereas this is actually looking out for that. Another key aspect of this is that it's not just going to do the sensing, but it's also going to do restart prevention. So if something interacts with it, it detects any form of motion, you can have it stop the system and then continue waiting for the operator to leave or for a fork truck to exit a work cell. And then you can either have it do an automatic restart where it's going to detect 4 seconds of no motion on most of the current sensors. I believe that went up to 8 seconds on some of the older sensors and controllers. Once it senses that environment, it's going to go ahead and start back up. Or if you have it on a safe manual restart mode, it's going to wait for that 4 seconds of no detection. You can have monitor by Modbus or through a digital output, send a signal that, hey, we're good to go, have an indication light, and then have a manual reset input. So that's a safe manual system that you're operating in.
Nice. All right. Yeah, this seems like a technology with a lot of different applications, with a lot of advantages over some of the traditional, optical type technology. Cool. Yeah, when I was perusing the website at Inxpect, they had this, what I thought was, they had some really cool videos kind of illustrating, I guess, through, not necessarily through filmed video, but through drawn video of some of their applications. So let's take a look at this restart prevention video that we pulled from the Inxpect website. Yeah, I love those videos on their website. I gotta believe that guy who was inside the cage there while his buddy tried to restart the machine probably wasn't real thrilled when he realized what his buddy was trying to do there. But the technology's there for a reason, right?
Absolutely.
All right, very cool. All right, let's get into some of the sensors now. You know, looks like there's a variety of different sensors available. What's kind of the difference between them in general?
Yeah, they've come out with a lot of different models, both for the sensors and the controllers over the years. Some of the key differences is just what exactly you're looking at in the application. It's great to have some of the AW sensors where you're able to actually lop off in what they call corridor view, which you can configure in their software, where you can take it down to a set width for the system instead of a conical output. That way, if you have, let's say, some hard guarding on the left and right, that's a 2-inch mesh that you don't want it to be picking someone up on the other side of it, but you want to have this go out for several meters looking out in the distance. It's easy to configure that where it'll just bring the sides in there for a corridor. Asymmetrical views, so if you only want to go 20 degrees on the right, 50 degrees on the left for your viewing area, as well as some longer range models that are coming out here. We have a lot of requests for that for mobile applications, AGVs, cranes, hoists. So it's great that Inxpect is listening and coming out with these new models as the market demands it.
Yeah, so I see there on those bottom three sensors, those have like a 9-meter range advertising there, right?
Absolutely. That is currently the longest range sensors that have come out. The other standards are 5 meters for the more basic sensors that are towards the top there. And we've seen a lot of success with both models, but especially a lot of good feedback from the 9-meter range.
Great. So if I remember correctly, this is kind of the sensor that you were using for your demonstration system in Pewaukee.
Yes, it is. So as you can see here on the right-hand side, we're showing the asymmetrical views as well as the corridor views. And one nice thing about these sensors is we actually mounted ours upside down. So it's on the bottom of our fencing demo, mounted it to a 44 by 44 channel that we use with our solutions group to do custom fencing. And it was nice for two reasons. One, it showcased the fact that you can configure this pointing the sensor in what would normally be considered the downward direction, and then the software inverting that. But it was also nice because these fencing segments are 7-8 feet tall. And when we're trying to demo the fact that you can monitor disconnects between individual sensors and diagnosing where that break in the system might be, I don't have to get up on a ladder and try and disconnect the one that's 8 feet in the air.
Yeah, so that gives you a lot of flexibility, not just for demonstrating, but I'm sure in the real application for where you mount these things. Very cool.
Absolutely.
So I understand. Okay, so on the control unit side, I think earlier you mentioned that for each of these control units, you can have up to 6 sensors. So obviously quite a selection of control units as well. Kind of how do those vary?
Yeah, so the difference between the control units, obviously you can see type A versus type B. That's primarily a form factor difference. So the type Bs are much more compact. They're going to be a slimmer design. Those are great. And we've seen a lot of success with AGV applications, the more mobile applications, and really just anything where you're in a compact area and you need to save a little bit of space. But we did use the 202A model on this one, which is the Modbus enabled version.
Right.
In addition to the Modbus one, they have different options, 202A and B-P models for Profinet,
Sure.
as well as some FSOE models. And soon coming out, they're going to have some SIP-safe models as well.
Okay. Yeah. So pretty much any way you want to interface with these guys, they pretty much can handle it, it sounds like.
Absolutely. They're trying to be very versatile and work with a variety of different Ethernet protocols, and as well as having the digital I/O on there.
Nice.
So one of the great things about being able to configure this in the software and being able to monitor it over Modbus is that you're able to use those 4 digital inputs and 4 digital outputs, or 2 dual channel redundant safe inputs and outputs, to really control the system in the ways that you want to, and then monitoring the non-safe contacts over Modbus or getting additional safety output over various protocols.
Okay. So there's obviously configuration software that you just mentioned. Now that's free software, right? It doesn't cost anything extra?
It is free.
Okay,
Yep.
very good. So what are the sorts of things that you're configuring in the software?
Absolutely. This is going to be the number of sensors that you have, which sensors you have, the type of sensor, and the type of controller you're using. You're going to actually set the position in a simulated room. And this is great because you can pull and overlay different images, different drawings of your work cell, and then place the sensors in different areas. You're going to control the field of view that you're looking at, so you can kind of trace out a map like you can see on the first and third images there. And then when you click into the individual sensors, you can set multiple configurations. So you can set different sensor groups. So if 1 and 2 go off, or if 3 and 4 go off, you can get different outputs from those. But you can also have dynamic configurations where when you get one of those dual channel safety inputs, you can say, okay, I want to mute, or I want to set a different configuration, or I want to monitor stack objects for sensors 1 to 2, 3, and 4, or the whole system.
Sounds like a lot of flexibility there. So
Absolutely.
obviously the way these guys interface with the rest of the control system, at least in the case of the Horner OCS All-in-one Controller, is over Modbus. So what are the types of data that's being shared over Modbus with the system?
Absolutely. We did 2 different scans in the Horner of 13 words each, I
Uh-huh.
believe. The first 13 there being our general system outputs. So that's monitoring the entire system, all 6 sensors in series, and the controller status.
Got
And
it.
then the second bench was obviously a little bit smaller than it could be for that scan because we're only using 2 sensors instead of 6.
Got it. So if you were
But
using
that's
6 sensors,
monitoring.
you'd be reading more information.
Absolutely. And you
Okay.
might want to break that out into a couple of different scans. But we tried to keep this having pretty fast scan times on here. And we just had the 2 sensors in the application. So it gave us the flexibility to monitor everything that we needed to.
Absolutely. Yeah, that sounds good. And then this is what the overall system looks like, right?
That's correct. I believe you have another picture here as well of what the actual inside of the panel looks like. But interfacing with the Modbus communications between the Horner X10 and the control unit, the 202A. And then the 202A communicates with all the sensors on a CAN bus network. So configuring all 6 of those in series. And one thing to note is that when you are ordering these, you want to make sure that you have a terminating resistor, just a little M12 device that clips onto the end of the last one to cap off that series at whatever the end is. And then that communicates back through your controller, configure based on the software, and generates the outputs that you're looking for on the Modbus network.
Yeah, yeah. The always, of course. I'm sure the reason they used CAN is because of its robustness. I mean, you can't get a whole lot more robust than CAN. And for a safety system, I mean, it makes a lot of sense. And a point that I just wanted to make that we talked about earlier, it's definitely a proprietary CAN-based system. It uses the CAN chips like we all do for all the different protocols, CAN Open and Horner CAN, as well as this Inxpect CAN network. So it uses the same chips, but they don't talk the same language. So it's designed to be a closed system from the standpoint of the sensors to the control unit, correct?
That's correct. You want to run these sensors back to the controller and then communicate out from there. You would not want to try to configure these up to a PLC, a safety PLC, anything else
Sure.
other than their control units.
Yeah, that makes sense. So here's a kind of a shot inside the cover of the panel. This is a panel at your Pewaukee office. Did you build this?
Yeah, this was built. We did the modifications to the enclosure, the solid non-metallic enclosure through our solutions group. I did all the assembly for this. And then we tried to feature a lot of our different products and how they interface with the Horner.
Sure.
We love Horner as a partner, and you guys play really well with a lot of our different products. So we have a pill safety controller in there. We have a Phoenix network switch, obviously our Inxpect controller, and then the Horner OCS.
Looks good. Awesome. Nice job there on the wiring. Okay, well that does it for kind of the look at the technology and the block diagram of the system. Next, let's kind of get into Cscape and take a look at that Modbus configuration. All right, here is one of the programs that Adam developed as part of his demonstration system. And I did something a little fun. I wanted to test out the program conversion. Adam developed this for an X10 unit. He also had a X4 unit. So he has 2 programs, one for an X10, one for an X4. Those are both micro OCS units. So actually what I did was I took the X4 program and I just loaded it into a Canvas unit using Cscape 10, and it automatically scaled all my screens. And I went back and did a little bit of touch up, but for the most part, it scaled everything pretty good. So that seemed to work well in Cscape 10. Just another plug for Cscape 10 here. Okay, so Adam, really the big part of this application is really just probably the Modbus configuration, right?
Absolutely. The rest of it's a pretty standard demo, but we really wanted to highlight the fact that Horner made it incredibly easy to set up the protocol communications with the Modbus.
All right, very good. So I'm going to go ahead and access the Modbus TCP protocol through the Protocols button here on the Project Navigator. Down here under Ethernet is Modbus client, so that's obviously Modbus TCP client. You know, here's our configuration. Modbus TCP, obviously, using the you know, good 1 second timeout. Pretty easy to meet that, no problem. you're pulling this as fast as you can, which makes perfect sense, right? You're gonna pull that just as quickly as possible. You've assigned status so you can see that everything is communicating properly or not. That looks good. And then we've got under devices here, here's our Inxpect device. So we've got the standard IP address for your demonstration, hard-coded, of course, the standard Modbus port number, and it looks like you use generic decimal addressing for this. So you've obviously got several choices when you're going through the Horner options for Modbus, and then you're taking advantage of the status here. So everything looks pretty standard so far.
Yeah, and one thing to highlight on this tab with the choice to go with generic decimal addressing, we actually did not originally have that. We were going with Modicon 5-digit or 6-digit addressing. We were playing around with it, trying to figure out exactly what we needed to use there. And we did run into a little bit of issue here, specifically on making sure that we were setting up correctly to communicate with the Inxpect controller. And we found out that the best way was just using the generic decimal addressing, starting with our scan list in the RWR 4000, and then tying that in with register 4000 was how we chose to do that out, just to make sure that it was all staying consistent with what we were seeing in the Modbus setup guides from Inxpect.
Nice. Yeah. And, so you've obviously got, so you're reading. If we take a quick look here, so this is a read-write register function. So you're probably since you're reading multiple registers, I believe that's function code 3, whatever. It's the one of the ones that you need for reading Modbus address starting at 40,000, and you're reading 13 in a row. So this is where that generic or the system level feedback is coming, right?
That's correct.
All right, and then your second entry in the scan list, starting at R4100. Okay, so that's taking care of the individual sensors for the first 2 sensors?
Yes, so that's 7 words for the first sensor, 7 words for the second sensor.
Nice. Okay, looks good. All right, and I mean, once you've got the data in the system, I mean, this is all read data, right? Are you writing anything, or is it strictly reading?
We're not writing anything out. We're just focusing on the read data here. And another thing that was incredibly helpful when we were setting this up under the network tab, when we went in and configured it to TCP and then set our timeout and reacquire times, that protocol help button in the bottom corner.
Yep.
That was invaluable when we were going through and troubleshooting some of the confusion that we were having when we were doing this as the 5-digit addressing or the 6-digit addressing.
Yep, absolutely. And one thing, it looks a little different than what you looked at when you developed this program. I think you developed this program in Cscape 9.9. Is that correct?
I did.
Exactly. This is Cscape 10. So the help file has been completely redone. So, but just like you said, when you're talking about protocols and things, especially, those help files come in useful. All right. Looks great.
Absolutely.
All right. So that's pretty straightforward. Thanks for the run through there. All right, so finally, we're going to take a look at a short 5-minute video of Adam kind of demonstrating the system to his colleagues at PowerMation. So the technical sales guys, the technical team, so that they know not only how Adam integrated these components, but also he kind of showed off how they could demonstrate the system both at the office for their customers as well as with a mobile kit that he created as well. Let's take a look.
So as you can see now, we have this on the automated restart motor simulation screen. So you're saying that we have the rotating gear or motor here. We have the motor speed RPM on the top. Again, this is all simulated, and then the status that's running. If you step into the far field detection, they caught me in the near field there. You can see that it goes to a red stop condition, bringing a flashing light coming out of here with the non-safe communications over Modbus of the Horner. So we're not burning a safe output because it's 4 digital outputs on the Inxpect controllers, 2 dual channel safety outputs. The capability of running all of this through the Horner is that we're not burning those safe outputs to do something like indication. You can reserve those for wiring into an interlock or to a safety controller, and then use the non-safe communications method through the Horner to actually drive your less critical processes, the things that are showing an operator what to do, but it's not directly impacting their safety in the circumstances. If you hit the return button here and go to the main screen, you can see we have controller inputs. We're actually simulating both a safe manual and an automatic restart here. So if we switch over to safe manual, you can see that the motor simulation now goes from just an automatic restart to, if you trip that near field detection, you get a 4-second countdown, 4-second safe restart. But then instead of actually starting back up when that counts down, you're getting a green light here, green light up there. We haven't restarted the motor yet though. You need a manual input and then you'll get your running condition. Additional features on here, we have the register data. This is calling out pretty much all of the critical things that Jeff and I wanted to highlight that you can detect through Modbus communications. So it has which sensor you're detecting, which field you're detecting. So let's see if I can trip just the one in the corner here. There we were able to isolate just the quadrant of the region that you were detecting in. We also have right side, left side sensor faults. This is a great way to demonstrate that if you have 6 sensors wired in series here, and one of them goes out, let's say it's the 4th sensor, you're going to get a trip on 4, 5, and 6. 1, 2, 3. 1, 2, and 3 are going to stay the same.
Okay.
You know that you have at least an issue with the 4th sensor, if not an issue with 4, 5, and 6. If you remove that 4th sensor out and just connect into 5, and then it goes back to running, you know that 4th sensor is the issue. It's a great way to isolate where the issue is if someone drives over a cable or something for reason breaks. You also have our sensor muting, static object detection on here, as well as redundancy input errors. So the way that you can simulate those is if you go into your controller inputs and turn on one output, you can see we're getting a flashing red here. It's getting an input redundancy error because you only have one of the 2 saved inputs triggered. Turn both of them on, then we're going to go into a 4-second safe restart. As long as it's not picking anyone up in the background, we'll go green. It'll stay green because the sensor's muted. You turn that off, turn on static object detection on the bottom, and then if we drag this table in, for instance, it would tell you not just that it's detecting something, that would be your general output, but when you go back to that register data, you can actually tell exactly which quadrant you are detecting it in to know where that static object is. That can be a great way to troubleshoot if you leave something in an area. You don't need to walk around everywhere that the sensors are covering. You can see exactly, oh, it's in this 5-foot by 5-foot section. Turn those back off. And I always try to leave it on automatic restart. I think it shows the best for a customer walking in and just going up and poking stuff on there. But it's a little bit more straightforward than knowing that you need that manual input. And finally, we have the zone view on here. This is going to differ between the mobile demo and the standard demo because obviously we only have one sensor on the demo. It's the standard Inxpect demos that you've seen and may have carried around. On here, it's great because you can show which regions you're tripping. And there is a lot of overlap between specifically the far field and the near field, so don't be surprised if you go ahead and trip both of those. This was a little bit tricky to do on this unit. We actually had to mess around with doing some stuff in PowerPoint, isolating the images, and then taking that transparent background image and pasting it into here as a bitmap. In the future, we'd like to get a canvas unit in here. We can really do a lot more with the graphics, especially the built-in graphics on that, and probably make this look a little bit cleaner. But we wanted to have some way of showing this off that you didn't need to hook up to the Inxpect software. Speaking of hooking up to the Inxpect software, you have an RJ45 port on the back that wires into a Phoenix network switch, managed network switch. So if you plug in there to your laptop, you can hook up to the Horner, show off the program, and you can also show off the Inxpect software.
So Adam, outstanding job. Very impressive. So I understanding that was kind of the last step past your, I guess your kind of indoctrination program at PowerMation. So what's next for you?
Yeah, so this was kind of the last step in me rounding out my TSA program, presenting that to the sales force. And coming this fall, I'll be heading down to Illinois, joining part of our Illinois and Iowa team down in the Quad Cities, Peoria area. And very excited to be able to continue representing PowerMation in a newer territory for us. All
right, so I look forward to working with you as you sell lots of Horner products in the Quad Cities area, that part of Illinois and Iowa.
Absolutely.
All right. Thanks for joining us, Adam. Take care.
Thank you, Chuck.
Okay, that does it for our material today. This is a reminder, we're here every Tuesday at 2 o'clock, so don't miss us. If you can watch us live Tuesday at 2, you can give us your comments and questions in the chat section. If you watch on replay like a lot of you do, give us those comments and questions in the comment section, and we'll get those read and answered just as soon as we can. Okay, sign up for training. The year's slipping away. 2 more classes in 2024. Go to our website. There's lots of ways to interact with Horner. You can do it on our website at hornerautomation.com. You can go to our YouTube channel, like I mentioned on the last slide. You can also interact with us on LinkedIn. We'd love to be your automation supplier. All right, now we've got a big month for live streams in August. Plenty of more Cscape 10 content, to be sure. So check our website for all the different topics we'll be covering in August. All right, so you're going to have an opportunity to see us in August at the Advanced Manufacturing Expo in Grand Rapids, Michigan. That is a great show. And we've also got a presentation that Don Clutterbuck and I will be giving on AI. So we think it's going to be a good, informative topic, and we think the trade show is going to be terrific. We know last year's was for sure. Okay, so if you have not subscribed to our channel, don't hesitate to do so. It doesn't cost anything, and if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week when we pick up with the Summer of Cscape, let's all get out there and do some good.